Today we have another medium problem, delete node in a linked list. So in this problem, we are given a singly linked list. Okay, so actually we are not given a simply linked list. We are given a reference to a node of the linked list. We are not given the head of the linked list. Okay, so what does this means is, let's say this is our linked list. Okay, and it would have some addresses. So let's say it is 100, it is 200, it is 150, and it is 3000. Okay, it can be anything. So these are the addresses, and what we are given is, we are given this value, this address. We are not given the value of the node. Okay, we are given its reference or the pointer to that location of the node. So what we have to do is, we have to delete it from the linked list, and what we are not given is the head. So we cannot traverse from here to that node or the node before it and then remove this pointer from here and attach it like this. This is not possible because we are not given head. We are given reference of this point of this node only. So we cannot change this pointer, we cannot move this pointer. So how can we approach this problem? We can approach this by copying the elements. Okay, what I mean by this is, let's say this is our linked list, 1 2 3 4 and 5. Okay, so what you have to do is, let's say we are given the address of this node. Okay, so our pointer is at this node. So how will you delete it? You cannot just simply delete this node, because else this pointer will be set to null and we will lose track of this linked list. Okay, so what we will do is, we will copy this 5 in this 4. Okay, we'll copy this 5 in this 4, and whatever be the value here, let's say it's 4 or 5. Okay, whatever it is, we will have to set the last or the second last node to null. Now this should be set to null. Okay, so it was just the second last node. So let's take a bigger example. So in this example, we can take random values, 1 2 7 11 -1 14. Okay, and anything you want. So okay, another thing to know is that the elements in the linked list are unique. Okay, so that does not matter that much in this question, but the thing which matter is that we don't have the node to be deleted. Okay, is the last node. Okay, that is not the last node. So how can we remove this is, if it was the last node, we couldn't, because we need to set this pointer to null, and this pointer lies with this node. Okay, so that is why in the question it is mentioned that it is not the last node. Okay, so this can be any of these node that is to be deleted. So how can we do that? If let's say we have to delete 11, so what I'm saying is that we can copy these, the next element, as from this node you can access the node ahead of it and copy its value into this node. Okay, so what would it be? It would become -1. Okay, and now you can copy this 14 also here and move this ahead. So 14 will come here, and now you will copy this 15 from here, and it will have 15 only, as we are just taking the value from the front node and saving it in the current node. Okay, so as you can see that here it was 11. Okay, so we have removed 11, and the order of the elements is same, as in that 1 to 7 and -1 14, and it had 11 here. So the elements before 11 and elements after 11 are in the same order. Okay, so how are we going to do that? Let's see the code. It is really simple and short code. So we have the function delete node. It is of void type. So void delete node, and it will have a list node, and its name is node. So what first we will do is, let's take that this node in the example that we have taken earlier is just this -1. We have to delete this -1. So how we will proceed is, we will make another list node which will be pointing to the next of our current node. Okay, so what we will do is, list node, let's say it n1, you can also say it next. Okay, and it's pointing towards the next of node, next node dot next. Okay, so what we have here is that our node is now here, and we have an n1 node which points to this 14. So now what we have to do is, to delete this one, we just have to copy the value from n1 to node. So we will do that, but it is to be done in a while loop because we have to do it for all nodes. Okay, so let's make a loop here. While we will write the condition here in a bit. Okay, so let's say we are moving, and what we have to do is, we have to copy the value from the next node into the current node. So node dot val is equals to n1 dot val. And as you have done this, now you need to move both the pointers ahead. Okay, so what you will do is, you will move this n1 here, and you will move this node here. So how can we do this in a code is, that node dot next, sorry, that our node is equals to node dot next, and our n1 is equals to n1 dot next. Okay, and yes, that would do that. So now let's copy, this value would have been copied, so it would be 14. It was 14, and now as n1 is here, we'll copy this 15 here. It will remain 15, it won't be changed, as we are not changing the value of n1 in that iteration. And now we'll move to n1 to this node, and node to this node, and we will copy whatever the value here is. Okay, why is it 15? So let's say it was 16, so it would become 16. And now as our n1 is here, what we have to do is, as we have reached the second last node, we need to set this pointer to null. Okay, so what our original list before was 1 2 7 -1 14 15 16. Okay, so what we have done is that we have copied this 14 here, then 15, and then 16, and now in the last cell we are left with the repeated last value. So what you have to do is, you have to set this pointer to null. You have to cut off this, pointer to null, and automatically this node will be lost, and our linked list would be just up to this node, or up to this node, and this won't be accessed. So now we have our n1 here and node here. So if we now change this, okay, as our n1 dot next has become the null, that is our n1 at the second last node. So if we move this ahead, what would happen is that our n1 would become null now, and our node will come here, and we will lose track of this pointer which we had to remove. So we can't go any further. Okay, so let's see again what was the situation here. The situation was that our n1 is here and node is here, and we have copied the value of this from here. Okay, so what I'm trying to say is that what we need to do is, we need to insert here a condition that if our n1 dot next becomes null, then we will break this loop. We will come out of this loop, and now we have not moved this pointer ahead. We are at n1 is at last node, and node is at second last node. So what you just have to do after this loop is, you have to set node dot next is equals to null, and it's done. And now let's look at the condition. Till when did we move ahead? We moved ahead till our n1 dot next was not null. Okay, so now you have set this condition here that n1 dot next is not equal to null. Okay, and if you copy this condition here that n1 dot next is not equal to null, what would happen is that after you move this pointer here, okay, so what was here, it was 15 here, and it was 15 copied, and our node was here. We are going in the previous iteration once. Okay, and now you moved them ahead, and now n1 comes here and node comes here. As soon as this happens, your n1 dot next is null, so you will break from the loop. Okay, you haven't copied this 16 into here in the node, so either you do this, and after this loop you write this line again. Okay, or what you can do is you can just set this while to 1. Okay, what would happen is that this while loop will always be true, and after this value has been copied, only then this loop will be break. Okay, so that would be answer to this problem. Okay, I hope that you have understood this video. Thank you.